Okay, now we're going to go ahead and just do some examples from section 4.4. The first one, number 13, asks us to find the slope and y-intercept, and they give us this equation, negative 5x plus y is equal to 7. So the first thing we got to do is just go ahead and get y all by itself, and we can do that pretty easy. We get y is equal to 7 plus 5x. From here we know that our slope is going to be the coefficient in front of our x, which is just 5. So we say, yep, m is equal to 5, and our y-intercept, or b, right? I should have put b here, is equal to the constant value, including its sign. And it's a positive 7, so we say y-intercept is equal to 7. The second one, it asks us to do the exact same thing, find the slope and the y-intercept. We have this equation, 2x plus 7y is equal to 0. If we solve for y, we get y is equal to negative 2/7 x. So from this, we got to find our slope and our y-intercept. Again, the slope is the coefficient in front of our x, in this particular case, negative 2/7. So m is equal to negative 2/7. b, or y-intercept in this case, is equal to 0 because we see there's no constant term. We could go ahead and say plus 0 here, but that's not necessary since there's not a 0. So in this case, y-intercept is equal to 0. They want us to graph y is equal to 2/3 x minus 5. The first thing we do is we want to locate the point on our y-intercept, and it's negative 5. So here we plot 0, negative 5. So we put that point first. Next we use our slope to go ahead and get a second point. And remember, slope is equal to rise over run. If we have 2/3 as our slope, right? So m is equal to 2/3. We know we're going to rise 2 and go over to the right 3 because it's positive and positive. So from here we're going to rise 2, 1, 2, and go over 3, 1, 2, 3. So here we have 3, 2, up 2, over 3, and this is our second point we can plot of a slope is equal to 2/3. If we do that again, just to show you how easy it is, from this point we can go over 3 or up 2, whatever you want to do first, 1, 2, and over 3, 1, 2, 3, and we even get a third point. From here we can go and draw a straight line and connect them, and we've graphed our line there. Number 51, it looks like they want us to just graph these guys and tell if they're perpendicular, parallel, or neither. So the first thing we need to do is we want to always just evaluate the slopes. The slope for this first line, we get m is equal to 1. The slope for the second one is we get m is equal to negative 1. Well, remember for perpendicular lines are defined by having negative reciprocal slopes. Well, 1 and negative 1 are negative reciprocals. So we say these are perpendicular. Since slopes are negative reciprocals, they are perpendicular. And we can go ahead and graph it. I graphed it now for you. Here's the first line. I located my y-intercept, which is positive 3, right? 3. I put it right here, 0, 3. And to find my slope, I went up 1, over 1. Rise over run, because it's 1. That means 1 to 1. 1, 1. Bam. And I just drew a line through there. That's my first line. My second line, my slope, my y-intercept was y is equal to positive 1. I drew a little crazy here, sorry about that. But it went through this point, y is equal to positive 1. And here we have a slope of negative 1. So that means when we have a slope of negative 1, we say that is equal to either negative 1 over 1 or 1 over negative 1, right? Both of these equal negative 1. So we can use either of these relationships to go ahead and graph our second point. So if we're right here and we say, okay, we want to do rise as negative, okay, that's fine. That means we got to use this guy. Rise is negative 1. That means we go down 1. And then that means run is positive 1. We go over 1. So that point right there. So this point that we just graphed pertains to using this form. If we do the rise is positive 1 and the run is negative 1, well, rise is positive 1, we go up. A run of negative 1 means we go to the left, and it goes right there. So this guy refers to this second point. And you can see either way, whether we go this way or this way, we end up making another point on the line anyway. So we go ahead and connect the dots, and here's our line for the second equation. And of course we can see that they're perpendicular. And I think that is it. we have an exam next week, so study hard and don't fear asking questions. Good luck and have a good week.